दृष्टुं ज्वलन्तं सर्वतोमुखं नृसिंहं भीषणं भद्रं मृत्युं नमाम्यहम्. Dear students, in our last class we discussed about the ring chain isomerism, and also we take a compound and how to write the structural isomers, because it's a question. You have isomerism in our 11th class, and in our 12th class we have the organic compounds, oxo-organic compounds, alcohols, aldehydes, ketones. So a student can get a same question in 11th class, can get same question in 12th class, and questions also in entrance exam. So from every entrance exam, a JEE main or our NET, a student will have a question from isomerism chapter. So now let's come to take fourth example. Another example I am taking as an organic compound. See, this is a question, a general question for the board exam of 12th class. An organic compound has molecular formula C4H10O. C4H10O. What are possible isomers? What are possible isomers? Name them and classify. Name them, and this is a 4-mark question or 3-mark question. Sometimes it may come in your exam, and these are for 11th boys. You have a straight question in isomerism. Now C4H10O, when a question comes, many often you remember your question has the answer, so never remember the answer, think the question. C4H10, so what is this? This is CnH2n plus 2O. 4, 10 when you CnH2n plus 2. So CnH2n plus 2O is what? It can be an alcohol or it can be ether. The moment CnH2n formula can be an alcohol or can be for ether. So for alcohol we will write structures, for ether we will write structures. All the structures of alcohol will be functional isomer of ether, or all the structures of ether are functional isomer of alcohols. So you see how you nicely you have come. You have gone to alcohol. It can be an ether. So for alcohol, there are now comes for alcohol we write the structure. And then, but what is how many carbon atoms are there? There are 4 carbon atoms. So when a carbon atom has compound has 4 carbon atoms, it can be different chains, because I told you while discussing isomerism, the chain begins at 3rd carbon atom, at or behind 3rd carbon atom. When an organic compound has more than 4 carbon atoms, the 4 or more than 4 carbon atoms, there can be different possible chains. So you first write CPFM. So first write possible chains. On the chains write possible position of functional group, position. Then F for the same compound, what are the functional, and among them find out the metamers. You see CPFM. So what are the things it can exhibit? It can exhibit C, it can exhibit P, it will exhibit F, and it will also can exhibit metamerism. So if you go by this, you will never remember, you never have to remember it, and it's not a boredom for you. You can write. So what are the when 4 carbon atoms are there? There can be 2 possible chains. So I'll now here I am writing for 4. I can have one chain C, C, C. I can write the 4 carbon like this, or I can write So 1 carbon, 2 carbon, 3 carbon, 4 carbon. So at the third carbon atom, keeping constant, I will have a chain. So third and fourth I wrote, and here are the C. These are C, 2 C's are there. C and C and C. This on this will have PF, on this will have PF, and for them will have the metamer. So this thing, then C is what? For metamerism, we can have C, then O, C, C, C. So these are ether. Now on this we will have different chains. We can get structures for isomers for this. So 3 possible chains are this. For A we will write PF, and for B we will write PF, and for C we will write this. So this is the way we will attempt our question when a student of second year. This is a question generally comes second year and also for first year student, 11th class and 12th class. Now let's come to A. So we can have, it is alcohol. It can be an alcohol or it can be ether. So first these two we go for alcohol, A and B we go for alcohol, and here we can write the OH, and here you can write the OH and get. So now then see. So first one we can write the 4 carbon atoms in a long chain and put the OH group here. 1, 2, 3, 4. This is one possibility. And second possibility, in the same chain, we will change the position of OH group. We can write C, 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 C. We can get the OH group to second carbon atom, OH group. So we are having here 1 carbon, 2, 3, 4, this possibility. Now for we will write this structure, for this we will write this structure. When you write for 1, what the 1 will be? It will be for 1, for A. What are the possible? Structure 1. You can write CS3, CS2, 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 OH. So this is 4 carbon atoms are there. So it is a derivative of butane. At 1 carbon atom there is OH group. So it was butane. Now hydrogen gone. So butan 1 all. It is a butan 1 all. And its common name will be what? There are the 4 carbon atoms are there. So in a long chain, it's called normal chain. So it is N-butyl alcohol. So the common name is N-butyl alcohol. It is an N-butyl alcohol. Then what? It is a CS2OH group. The CS2OH group is a primary alcohol group. CS2OH group is a, we have read alcohols can be of 3 types: primary alcohol, secondary alcohol, tertiary alcohol, depending upon the type of carbon atom to which the OH group is bonded. To which the OH group is bonded. So now, so here it is a primary, so it is a 1 degree alcohol. Now we'll come to second structure. Second structure. Here we can get the OH group, second structure. We got the OH group here. So CS3, 1, 2 gone, CS2, 1, 2, 3 gone, CH, OH, and this is CS3. So 1, 2, 3, 4. 4 carbon atoms are there. Butane and hydrogen gone, butan 2 all. Butan 2 all. Now this is then what will the common name? So this is a secondary alcohol. This is a CHOH group. Secondary alcohol. So we will say secondary butyl alcohol. This is secondary alcohol, secondary butyl alcohol, and this is a 2 degree alcohol. This is a 2 degree alcohol. Now this we have written. Now we will come to the, now this chain B. You will come to the B chain. So in the B chain we will write the third structure. So we can write C, 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 1, 2, 3, 4, 1, 2, 3, 4. We can write the OH group at 1 carbon atom. We can write the OH group at 1 carbon atom. and satisfy the tetravalency of carbon. So what will be this? So CH3, CH, CS2, OH, CS2, OH. So 1, 2, 3, and the substitution is a methyl group. So 3 carbon atoms are there. It is derivative of propane. It is derivative of propane, hydrogen gone, propan. At 1 carbon atom, OL is there, propan 1 all, and the same propane is attached with a methyl group as a substitution. So there is 2 methyl propan 1 all. Could you understand this? 3 carbon atoms are there, derivative of propane, hydrogen gone minus E plus OL, so propan 1 all. At 2 carbon atom there is a methyl group, so I write 2 methyl propan 1 all. Now if I write the common name, this carbon atom is an isocarbon atom because this carbon atom is bonded to 2 methyl groups. This carbon atom is bonded to 2 methyl groups. This is an isocarbon atom, and 4 carbon atoms are there, so it is a butyl alcohol. Common name I am writing. So 4 carbon atoms are there, it is a butyl alcohol, and one of the carbon atom of butyl alcohol is a iso one. So this my common name for this compound will be isobutyl alcohol. Isobutyl alcohol. Then what type of this is CS2OH. This is what? CS2OH. This is a 1 degree alcohol. This is also a primary alcohol. Now we'll come to and this we can have in the structure. We can get the OH group from the first carbon atom to second carbon atom. We are having the carbon atom here 1. Compounds having same molecular formula but different structure due to different position of the functional group on the same carbon-carbon chain are said to exhibit position isomers. On the same chain we have position isomers. So we will say this, will the OH group to this. So we have CH3, then COH, then CH3. We are taking OH, so this becomes CH3, so this becomes CH3-1. So this is what? A carbon atom is bonded to 3 methyl groups. So this is a tertiary alcohol. This is what? A tertiary alcohol. Then what is the name? Choose the longest continuous carbon-carbon chain. Choose the longest continuous carbon-carbon chain. How many carbon atoms are there? 3 carbon atoms. So derivative of propane. And OH group is bonded to OH group. So propan 2 all. And a methyl group is substituted at second carbon atom. So its name will be 2 methyl propan 2 all. 2 methyl propan 1 all, 2 methyl propan 2 all. Because same chain remains same, only position of functional group changes. So this is what? This is what type of alcohol? Carbon atom is bonded to 2 alkyl groups. When the carbon atom is bonded to 3 alkyl groups, it is called tertiary carbon atom. And OH group is bonded to that. Hence is a what? Tertiary alcohol. And how many carbon atoms are there? 1, 2, 3, 4. 4 carbon atoms are there. So it is a butyl alcohol, and the carbon atom is a tertiary state. So we write these as tertiary butyl alcohol. Its common name will be tertiary butyl alcohol. Tertiary butyl alcohol. So these are the 2 possible isomers for this chain, and the CP gone. Then we will come to functional. So all the alcohols exhibit functional isomerism with ether. Alcohols exhibit functional isomerism with ether. So for we will put this chain as a ether, and we will put that chain as a ether. This chain as a ether. We will write the structures for this, and this chain as a ether. So I will come to C chain. So 1, 2, 3, 4 gone. So 5 structure can be C O, C, C, C. I can write like this. So this will be what? CS3. This compound is CS3, O, CS2, CS2, CS3. This is the ether. You see this chain. I am writing this chain. So I am writing this CS3, O, CS2, CS2, CS3. So this is propyl group and propyl group. This is methyl group. So while writing the common name, the rule is the common name is written what? By writing the alkyl groups in alphabetical order. So let us, because we are writing the first IUPAC name. So 1, 2, 3. This is a propane. One carbon atom of propane is bonded to a methoxy group. One carbon atom propane is bonded to a methoxy group. So we will write as IUPAC name is 1 methoxy propane. 1 methoxy propane. We can write this as 1 methoxy propane. So it is a ether, and IUPAC name is methyl and propyl ether. Its common name is methyl and propyl ether. Now on this we will change the OCH3 to second carbon atom. So we can write this as what? We can write this as CO. We will take this to second carbon atom. Just like this. 1, 2. Here also we made 1, 2. So this is CS3, this is CS3, this is CH, and this is CS3. So this is the methoxy, is the substitution bonded to this. So 1, 2, 3. So these 3 carbon atoms are there. Propane. 3 carbon atoms are there, derivative of propane. And 2 carbon atom is bonded to a methoxy group. So 2 methoxy propane. 2 methoxy propane is the common name. I am sorry, IUPAC name. This is a IUPAC name. Common name. So this is methyl. This is methyl. This is isopropyl. So isopropyl methyl ether. Isopropyl methyl ether. Isopropyl methyl ether. Now we will come to its 7th structure. We can have 2 carbon atoms one side and 2 carbon atoms on the other side. We can have 2 carbon atoms one side and 2 carbon atoms other side. So this is CS3, this is CS2, this is CS2, this is CS3. So this is ethoxyethane. Its IUPAC name ethoxyethane. Alkoxyalkane is the name. Ethoxyethane, and common name diethyl diethyl ether. So we got now 7 structures. Out of 7 structures, 4 are alcohols and 3 are isomers, 3 are ethers. So suppose a question comes in an entrance exam, organic compound C4H10O has the number of isomers 3, 4, 7, 6. So they will have 7 isomers. If you have how to know, if you do it, once you do it, you need not, many often people remember the things. We do not want to remember. We can write ourselves. Once we decide how to write, so alcohol, this, now we will classify them. We have done write the possible structures. We wrote the possible structure. We have named them. Name is over. Then classify. What will these? 1 and 2. 1 and 2 are what? Position isomers. So now we are classifying them. 1 and 2 are position isomers. 1 and 2 are position isomers. Then what are 3 and 4? 3 and 4 also position isomers. Why? It is at 1 carbon atom all and 2 carbon atom all. So 3 and 4 are position isomers. 3 and 4 are position isomers. 3 and 4 are position isomers. So 1, 2 alcohol, 2 are there. So 1, 2 is a long chain and 3, 4 are a branch chain. So we will say 1 and 2 are chain isomer of 3 and 4, because 3 and 4 are branch chain. 3 is a branch chain, 3, 4 is a branch chain, but 1 and 2 are normal chain. So 1 and 3 and 4 are 1 and 2 are chain isomer of 3 and 4. Now 1, 2, 3, 4 are alcohols. 1, 2, 3, 4 are what? Alcohols. Whereas 5, 6, 7 are ethers. They are ethers. So we'll write here. 1, 2, 3 and 4 are functional isomers of 5, 6 and 7. 5, 6 and 7. Because 1, 2, 3, 4 are alcohols, 5, 6, 7 are ethers. So 1, 2, 3, 4 are functional isomer of 5, 6, 7. Now we will come to relationship between 5, 6, 7. So 5 is a 1 methoxy, 6 is a 2 methoxy on the same propane. Chain remaining same, position change. So 5 is a position isomer of 6. So 5 is a position isomer. So this is 1, we are classifying them. 2, then we are classifying 3, and we are classifying this 4. Then another we are writing this as what? 5 and 6. 5 and 6 are position isomers, because 1 methoxy, 2 methoxy, propane. So they are position isomers. Then if you come to 1 and 2, 5 and 6 are one type of chain, and this is another type of chain. So 5 and 6 are, what is happening? They are what? You have this side ethyl, this is the ethyl ether. So an oxygen atom, this side you have 2 carbon atom, this side 2 carbon atom. But in this side 1 carbon atom, other side 3 carbon atom. And on this side 1 carbon atom, other side 3 carbon atom. When compounds having same molecular formula but different structure due to different possible arrangement of the carbon atom on either side of same functional group are said to exhibit metamerism. And each structural form is an isomer, is a metamer of the other. So here on oxygen you have 3 carbon atom this side, 3 carbon atom this side. So they are one type of metamer, and here on oxygen you have 2 type of carbon atom, 2 carbon atoms. So this is different because of different arrangement of carbon atom on either side of same functional group. So what will say? 5 and 6 are metamer of 7. So we will say 5 and 6 are metamer of 7. A critical question may come in your NET exam. The number of metamers possible for the structure C4H10O. Gone. 1, 3, 2, 4. 4. So how many metamers are there? 2 metamers. So you will have another 5 and 6 are metamer of 7. 5 and 6 are. So these are the 5 and 6 are metamers, 3 pentamers. So 5 and 6 are one type, 7 are another type. Metamer 7. So you have now the entire organic compound has molecular formula C4H10O, right? The possible isomers, classify them, name them. Classify them, name them. This is a full question a student of second year in Odisha board can get for 7 marks. For 7 marks. If write one, you can get 7 out of 7. Very easily one can score. And this is the way also teaches you different type of alcohol. So this is another question you got. This an organic compound has molecular formula 7. Now let's take another compound. So we know that aldehyde. Another question I am giving you, discussing one question to you on the writing the structural isomer of a compound, where one start thinking there are no isomers, no possible isomers cannot be possible, because let's take an example. Right, an organic compound has molecular formula C2H4O. C4H4O. Write the possible isomers and classify them. Question comes. This is a 12th class question and can be also 11th class question. So a student of 11th class and 12th class should clear this. So C2H4O. What is this? This is CnH2nO. So what is this? An aldehyde. So what will be aldehyde? COH. So this is CH3, CHO. So we know an aldehyde is a functional isomer of ketone. But a ketone has to have 3 carbon atoms. Why? R, CO, R. At least 3 carbon. So people, no isomers. Answer will write no isomer. But we can change this C2H4. We can write the C2H4. So we can write this in aldehyde. CnH2n is what? An unsaturation. CnH2n plus 2 alkane. CnH2n alkene. CnH2n minus 2 alkyne. So the CnH2n can be an alkene structure. Can be an alkene structure. So we know CS2 double bond CS2 ethylene. CnH2n is what? CS2 ethylene. Suppose we remove one hydrogen atom here, CS2 double bond CH, then O, then H. We can write like this. How I am attempting this? I am writing for the carbon skeleton. CS2 double bond CS2. What is there with me? One O. So I want to write a O, but I cannot write O here. To write O, I have to remove hydrogen atom. I remove the hydrogen atom and wrote this here. So it can be an alcohol. So this can be an alcohol. So I can be CS2 double bond CHOH. So this is what is acetaldehyde. This acetaldehyde or ethanol. Its IUPAC name is ethanol. And now when you come to this, so this is CS2CH group. This group is called vinyl. CS2 double bond CH group is called vinyl. CS2 double bond CH is called vinyl. CS2 double bond CH CS2 is called allyl. That is called as allyl. So vinyl. So this is vinyl and OH alcohol. So its common name is vinyl alcohol. Generally people write it cannot have isomers. So it is a vinyl alcohol. And IUPAC name will be 1, 2. It is ethene. So this is ethanol. Ethene, ETHEN, ethene, E gone. It is ethanol. Means it is an alcohol having 2 carbon atoms and a double bond. See, IUPAC name tells everything. OL alcohol, it is an alcohol. EN, it has a double bond and 2 carbon ethanol. So what will be they? They are what? Functional isomers. They are what? This is an aldehyde and this is a ketone. This is alcohol. So they are what? Functional isomers. So vinyl alcohol is des of ethanol. Because you have aldehyde, you have alcohol. 12th class students, you have a question, you have both the things you have in your course. You have aldehyde, you have alcohol. So a question may come to you in the exam, acetaldehyde is des of vinyl alcohol is a functional isomer of vinyl alcohol. Vinyl alcohol is this of acetaldehyde, a functional isomer of acetaldehyde. So this is the way you can write this. Another way we can write what? We can have CnH2n. So we can write CS2 and O, this C2H4, C2H4O. A ring structure. We can have a ring structure. This is ethylene oxide. This is ethylene oxide, or its another name is epoxide. So we'll say what? 1 and 2 are functional isomers. 1 and 2 are functional isomers. And 3 is a ring chain isomer of 1 and 2. So this is a question you can have this. So or you may have the ring chain isomer of vinyl alcohol is or acetaldehyde is. Question maybe they fill up the blanks may be there, because you are having 1 mark question, 2 mark question, so there also you can have, or both the structures then can give and ask a question. So once you are equipped with a fundamental concept, then begins your knowledge. So always, my dear students, you try to increase your fundamentals. Don't be type of many often what happens in classes, what they do, they go on writing like a machine. They use a laptop and they go on prepare the question and put on the laptop, and people say that wonderful class. No, increase your fundamental, try to know the basics of the chemistry, and once you are enriched with that, you will click your entrance exam in one chance. So this is that which I wanted to tell you about structural isomerism. I will take classes on the stereoisomerism, where I will discuss geometrical isomerism and optical isomerism separately. So thank you very much. So you can wait for the next class, that is isomerism, the stereoisomerism. You will have the optical isomerism and geometric isomerism in organic compounds. Thank you very much.